Gradle Enterprise provides build caching for both Maven and Gradle builds. It also comes with tools to monitor, optimize, troubleshoot, and administer the cache infrastructure and the cache effectiveness. Let's use a real-world project to get some real numbers. Many of you are using the Spring Boot project. The Spring Boot team is a user of Gradle Enterprise, and they allowed us to use their real-world data for demonstration purposes, which is awesome, and I want to say thank you to the Spring Boot team. What I will show in the next and final demos is a little bit more in depth than the previous examples. I hope you will enjoy. Let's go to the trend dashboard and look at their CI builds. I want to explain a little bit the metrics on this page so that we can later better understand the impact of the build cache for the Spring Boot project. Build time is a simple metric. It is the wall clock time between the start and finish of a build. Next is the serial execution time. This is the sum of the execution time of all build actions. To understand this a little bit better, let's go to the timeline of a single build from the Spring Boot project. Every rectangle here represents a build action. The serial execution time is the sum of the lengths of all those rectangles across all the rows, whereas the build time is the length of a single row. Those white spaces in between the rectangles are, for example, caused by build actions having to wait for the output of other build actions. The more white spaces you have and the less rows you have, the closer the serial execution time is to the build time. The minimum for the serial execution time is the build time, and the maximum is the build time multiplied with the number of processes, in this case 4 times the build time. The ratio between serial time and build time measures how much faster your build time is because of parallelism. The Spring Boot build is an average 2.6 times faster out of a theoretical maximum of 4. This is pretty good utilization. If they allocated, let's say, 12 processes to this build, 2.6 would mean it is a significant underutilization of the provided compute resources. Now we have all the context to reason about the next number, which is called avoidance savings. This is basically the execution time savings you get from caching. Now, fasten your seatbelts. The average execution time savings for every single CI build is 1 hour and 19 minutes. I repeat, 1 hour and 19 minutes for each and every build over the last 19 days. This is serial time, so in terms of the actual build time, build caching is making the CI build faster by roughly 1 hour and 19 minutes divided by 2.6, which is 30 minutes. So without the cache, the average build time would be 45 minutes instead of 15 minutes. Not bad. But you're not just saving 30 minutes of build time, you're also saving 1 hour and 19 minutes of compute resources. Resource effectiveness is another huge benefit of a build cache. For teams with smaller projects, of course, the absolute time savings will be lower. With the SLF4J project in the previous example, caching decreased the build time by only 26 seconds, from 39 seconds to 13 seconds. But if the same number of developers is working on multiple smaller projects, the absolute number of builds is higher. So you have to take this into account when you're trying to reason about the impact of a build cache.